If you want to design a tool to navigate one of the most delicate parts of the human eye, Schlemm's canal, a circular channel with unique vascular structure comprising characteristics of both blood vessels and lymphatic vessels, you run into a huge problem right away. The entire tool has to be impossibly small. The outer shaft of the iTrack Advanced Microcatheter is just 220 microns in diameter. To put that in perspective, that's about the width of 3 human hairs laid side by side. But the real engineering feat isn't just making something small, it's what's packed inside this micron-sized catheter. So how do you achieve that? The answer starts with the catheter's skin. Now, if you're making a standard catheter, you might reach for an off-the-shelf polymer like nylon. It's a workhorse material, it's strong, and it gets the job done for a lot of applications. But canaloplasty puts extreme demands on a material. You need toughness to protect the delicate inner workings, but you also need flexibility for the 360-degree journey. That's because the engineering principle is to be atraumatic. The goal is to traverse the canal, not tear through it, which means a general-purpose material that forces a compromise between toughness and flexibility just isn't good enough. So Nova Eye took a different approach. They engineered the catheter shaft from a proprietary polymeric compound, a purpose-built material for a design without compromise. But that's only half the story. To give this catheter skin a responsive core, you need something special inside. That something special is nitinol, a blend of nickel and titanium famous for being a memory metal. Its key property is superelasticity. It's up to 30 times more elastic than stainless steel, making the catheter highly kink-resistant, allowing it to spring back to shape after navigating tight curves. Crucially, this design also includes a safe fail mechanism. In extreme anatomy, the device will kink to absorb force rather than perforate the canal wall, giving the surgeon a definitive tactile signal to stop. But a catheter that moves perfectly isn't enough. The bigger problem? Navigation is blind. You're relying on tactile feedback alone, constantly asking yourself, did I make it the full 360 degrees? Am I about to push too hard and create a false passage through the suprachoroidal space or the collector channels? And no one likes that uncertainty. The solution is elegant. You give the device its internal GPS. A medical-grade optical fiber runs the length of the iTrack Advanced Microcatheter, channeling light from the portable iLumin light source to the tip. This creates a distinct red glow, visible through the sclera, a technique called transscleral visualization that provides visual feedback through every step of the procedure. But this illuminated beacon is more than just a locator. It's an interactive surgical tool.
The iTrack is great because it has a lighted tip that tells you exactly where you are at all times. And so it can tell you when you've hit an occlusion or you've entered a part of the eye that you don't want it to go into. And as a result, it tells you when to stop. The worst thing to do is try to force that thing through into an area that it doesn't want to be.
But there's one final challenge, the point of contact. The tip of the iTrack Advance is slightly larger than its shaft at 250 microns. And even at this scale, a simple flat edge can snag and damage the delicate wall of Schlemm's canal. That's why the tip of the iTrack Advance is engineered like the rounded nose of a submarine, designed to glide with minimal disturbance. Each one is individually fashioned by hand under a microscope, creating a smooth, bulbous shape that doesn't pierce a path, but gently displaces tissue as it traverses the canal. When you put it all together, you see that the iTrack Advance isn't just a catheter. It's a series of sophisticated solutions to a series of incredibly difficult problems. A complete system where every component is designed for one purpose: to give a surgeon mastery over the microscopic world of canaloplasty.